1.7 Solve linear quadratic systems. So an equation is a statement that that two expressions or quantities are equal. Okay, so an equal sign, so equation, equal sign, is always part of the equation. So for example, 4x plus 9 equals 17. Okay, this is an equation. Now to solve an equation, we need to find all values of a variable that will make the equation true. Okay, for example, x equals 2 makes this equation up here true. And when we solve, we call it a solution. So a solution is a value that when substituted in place of a variable, it makes the equation true. Okay, so x equals 2 is the solution for this equation. Okay, here's a little bit of a recall from grade 9 and 10. So when we solve linear systems, this means to find the point of intersection, okay, POI. We can use the method of substitution or elimination, and this method is solving a linear system by substituting one variable from one equation into the other equation. Now, linear systems can have three different types of solutions. It can either have 0 solutions, 1, or infinitely many. So when we have two parallel lines, such as these two, we have no solutions. So there are 0 solutions because the lines never cross. So there's no points that satisfy both of these equations. Okay, how to recognize? They have the same slope and different y-intercepts. Okay, now if we have two non-parallel lines, okay, as long as they're not parallel, they're going to cross once. So there's always going to be one point that satisfies both lines. How to recognize? Well, simply different slopes. Okay, and now the third one, infinitely many solutions. So this is two identical lines. So see how we have an equation here, and they're just multiplied by 2. Okay, so we recognize this because they have the same slope and the same y-intercept. So they're actually lying on top of one another. So say you had a green line here, your, let's say, blue line would lie right on top of the green line, and every single point on one line would satisfy the other one, and that's why we call it infinitely many solutions. Okay, so example 1, this is going to be a little bit of a review, but just to kind of make the connection between last year and this year, we're going to solve the following linear system by using substitution, okay, method of substitution. So we have y isolated, so we're going to sub in 3x plus 7 into the other equation, okay? So we get 3x plus 7 equals 2x minus 5. And now all we have to do is rearrange. So bring this 2x over, it becomes negative 2x. Bring this 7 over, it becomes negative 7. And we get x equals negative 12. So we take this negative 12 and we sub it back into either of the two original equations. So we can do y equals 3, negative 12 plus 7. So we get negative 36 plus 7, and I get y equals negative 29. Okay, so therefore POI, point of intersection, is negative 12, comma, negative 29. Okay, to extend on this into the grade 11 program, solving linear quadratic systems of equations. Okay, so now instead of having two lines, we have a line and a quadratic. Okay, and there are 3 possible solutions. So no solutions, there are no points of intersection. Okay, this is when, for example, we have a parabola and then perhaps the line is above or below the parabola. It could also happen where the parabola is down and then there's a line above it. Okay, so there's no intersection, and this happens when the discriminant is less than 0. And I'm going to show you how to find the discriminant of a quadratic and a line together. Now we could have one solution where the line and the parabola intersect once. Okay, this does not have to be the vertex. It could intersect here. I just wanted to show you guys with a very clear picture. Okay, it could intersect here. It could intersect anywhere. Not necessarily the vertex. Okay, and then this is called a tangent line. This will come back next year in functions and in calculus. Okay, this is a line that intersects a curve at one point and has the slope of a curve at that point. Okay, and this is when the discriminant equals 0. Okay, and then two solutions is when the line completely cuts the parabola. So there's 2 points of intersection. Okay, this is called a secant. Again, this will come back up in calculus. A line that intersects a curve at 2 distinct points, and this is when the discriminant is greater than 0. Okay, these rules very similar to what we already know. If it's less than 0, there's like no solutions. Equal 0, 1 solution. Greater than 0, 2 solutions. So I will show you graphically how to do this. We will most likely need to know this algebraically, okay? So graphically, you graph the parabola and a line and see if they intersect. Algebraically, you use substitution or elimination. Okay, so first graphically. So let's take this parabola and then this line, and let's sub in a bunch of points and fill in the table of values. So I have the table of values here. You can go ahead and sub in your points. Okay, so we get 20, 7, -2, -7, -8, -5, and 2. Okay, and for the line, I get 10, 7, 4, 1, -2, -5, and -8. Okay, so if we were to come over here and graph the parabola, it would go 0, 20, that's off of the chart, 1, 7, 2, -2, 3, -7, 4, -8, 5, -5, and 6, 2. Okay, so here's our parabola. Okay, now let's do green for the line. Okay, so let's go 0, 10, 1, 7, 2, 4, 3, 1, 4, -2, 5, -5, and 6, -8. Okay, and then we'll connect these. This is a line. Okay, so this is y equals -3x plus 10. And then in the purple, we have y equals 2x squared minus 15x plus 20. Now, taking a look at the graph itself, we can identify where the points of intersection are, or we can identify them from the table of values. Okay, so it is clear that we have a point of intersection here and a point of intersection here. Okay. Also, if we take a look at the table of values, we have 1, 7. Well, that's exactly where it is. Therefore, POI 1, 7, and we have 1, 7. So both of those, this point occurs in both the parabola and the line. And then the other one that's a duplicate is 5. So 5, -5, and 5, -5. Okay, and that's how we do this graphically. Now let's take a look algebraically. Okay, so here are the steps to solve a linear quadratic system algebraically. So we're going to set the two equations equal to one another, assuming that they're in the form y equals something, okay? So basically y equals y, or like the line equals the parabola, okay? Because what we're trying to actually solve is exactly this. When does the line equal the parabola? Okay, number 2, we're going to set the equation equal to 0. So we're going to bring all the numbers over to one side and set it equal to 0. I'll do this example 3, while I read through these, so it makes more sense. So we have 4x squared minus 15x plus 20 equals 5x minus 4. Okay, so parabola equals line. let's bring over the 5x, let's bring over the negative 4. So I'll just rewrite this. So 4x squared minus 15x, bring over the 5x, we get negative 5x, plus 20 plus 4 equals 0. Now let's collect these like terms here. We have 4x squared minus 20x plus 24. Okay, so we did 3 simplified by collecting like terms. Now, it says solve for x by factoring or using the quadratic function formula. Okay, note the solution will tell you for what value of x the function has the same y value. Okay, so let's go ahead and do that. We can common factor out of 4. Okay, so now we have 4x squared minus 5x plus 6. So what two numbers multiply to 6 and add to negative 5? Okay, so the factors of 6 are 1 and 6, 3 and 2. So to add to negative 5, we're going to have to do negative 3, negative 2. Because this is a positive 6, so they have to also multiply to a positive number. Okay, so we can just do product sum, x minus 3, x minus 2. Okay, and when we branch these off, we get x equals 3 and x equals 2. Okay, so note, the solution will tell us for what values of x the functions have the same y value, but it doesn't actually give us the coordinates. So you have to read the question carefully. If it wants complete coordinates, we have to plug the values of x back into either of the original functions to solve for y. So I'm going to choose the line because obviously this is way shorter and easier. So y equals 5, 3, minus 4. And then y equals 5, 2, minus 4. So 15 minus 4, I get 11. 10 minus 4, I get 6. So the 2 points that I get are 3, 11 and 2, 6. And then state your points of intersection. That's fine. Therefore, POIs are, and that's our therefore statement. Okay. I'm just going to reread, read for the first time the example 3, just to make sure that we follow the correct steps, okay? So, how many points of intersection are there in the following system of equations? And then determine the solutions or points of intersection of the following system. So we actually did B. I'm going to show you how to do A using just the discriminant, okay? So, when we get we sub in, we simplify, and we get this equation right here, right? So if we just want to deal with the discriminant, we would sub in, I'll do it here, b squared minus 4ac, and for this one we have a equals 4, b equals negative 20, c equals 24. Okay, b equals negative 20 squared minus 4ac. So we get a discriminant of 20 squared minus 4ac, 16. Okay, because 16 is greater than 0, therefore there are 2 roots. So how many points of intersection are there? There will be 2. Okay, so A, we use the discriminant, B, we actually go ahead and solve. Okay, solve the following linear quadratic system. So we have a quadratic and a line. This is not in standard form, so let's go ahead and expand it. Okay, so y equals 2. We have x minus a half, x minus a half, and then plus a half. Okay, if we FOIL this, we get 2x squared minus, we get a half times a half, which is 0.25. So we get minus a half x minus a half x plus 0.25, or a quarter, and then plus a half. Okay, let's add these. Y equals 2. we get x squared minus x plus, I'm going to change that to a fraction, a quarter plus 1/2. So let's go ahead and expand that too. 2x squared minus 2x plus 2/4, which is a half, plus a half. Collect those, we get y equals 2x squared minus 2x plus 1. Okay, so now we have a form of a quadratic that we can actually work with. Okay, so let's go back up here and let's equate these. So we get 2x squared minus 2x plus 1. Let's equate that to the equation of the line, 3x minus 5. We'll bring everything over. So we get 2x squared minus 2x minus 3x plus 1 plus 5. Okay, so collect these terms, minus 5x plus 6. Okay, so now this question wants us to completely solve. So what two numbers multiply to 12 and add to -5? Okay, so if I were to list these 1, 12, 2, 6, 3, 4, the difference of any of these combinations is not -5. So I'm actually going to do a check here. Let's check if there are any roots. So b squared minus 4ac. Okay, and just remember, 2 is your a, -5 is your b, and 6 is your c. So -5 squared minus 4 times 2 times 6. So we get 25 minus 48. This is a negative number. Okay, it's less than 0, so therefore there's actually no point of intersection. Okay, example 5. If a line with a slope of 4 has one point of intersection with the quadratic function, this, what is the y-intercept of a line? Okay, so a line with a slope of 4. So recall, the equation of the line is y equals mx plus b. So the slope it's saying is, which is m, is 4. Okay, so if this line, 4x plus b, intersects this, here we go, this parabola exactly once, one point of intersection, then we have to just solve for b. Okay, but we know if it's one point of intersection, then the discriminant equals 0. So let's bring these both over to the side. So we have 0 equals 1/2 x squared plus 2x minus 4x minus 8 minus b. Okay, let's collect these. 1/2 x squared minus 2x, and then we have minus 8 plus b. Okay, it's kind of like a little bit of a factoring, so we just like grouped 8 plus b. So the discriminant has to equal 0. So this is a, this is b, and this is our c. So discriminant equals b squared minus 4ac. So -2 squared minus 4, 1/2. Think about how to put this in here. Okay, you know what? Let's put it as plus, let's not factor it, plus 8 minus b, or -8 minus b. Okay, so I get 4 minus 4 times 1/2 is 2, and then I get -8 minus b. Okay, I get 0 equals 4 minus, let's distribute the -2 in, so plus 16 plus 2b. 0 equals 16 plus 4 is 20 plus 2b. Let's bring over the 20. -20 equals 2b. And divide out the 2. We get b equals -10. Okay, so let's go back to the original question and reread it. Write the equation of the line in slope y-intercept form. So the equation of the line is going to be y equals 4x minus 10.